Hi, guys, and welcome back to another episode of Women in Math and STEM, where our mission is to reach out to as many professionals, aspiring professionals, students, whatever you name it. We try to reach out to them, who essentially support the initiative of bringing more women and young girls into the STEM field. So, with that being said, as always, feel free to open up the description or transcript to better follow along, and I hope you enjoyed this episode. Hello, and thank you so much for coming to this call today and speaking with me. Just to sort of start off, can you walk us through what sort of got you into mathematics and your journey to get you where you are today?
Thank you very much, Angelina, and hello to your audience. So what got me into maths? So I grew up in Ghana and in school, I learned most questions. I could understand things, score almost a perfect score, but I didn't think it could be something I could pursue as a career. So I was working towards, in high school, I was thinking more of becoming a chartered accountant. So I took more of the accounting line. But as a blessing in disguise, I applied to college or university, and I didn't get my first choice, which was to be in the business school. So I second choice of mathematics. I went in, yeah, a bit disappointed at the beginning, but when we started learning, I realized that first maths was challenging. University maths was different from high school maths, so I had to find my feet there. But once I found my feet, I realized I really enjoyed solving the math problems. So in our classes, we used to have problem sheets for every week, and we were supposed to solve them. We would have tutorials, discuss some of them. I had a study group where I would meet with my colleagues and try to unpack some of the exercise sheets. So I found a lot of joy doing it in terms of the perseverance, right? You keep coming back at things until you finally get it right. And when that aha moment comes, you get that fulfillment. So I went on that path. Still not sure I could pursue maths professionally. Growing up, I didn't have my first female maths teacher was in university in third year. So even though I was doing math, I only thought of maths as something that's only teachers would pursue. What were the prospects? But after my undergraduate studies, I worked for 2 years as a teaching assistant, still exploring. And the African Institute for Mathematical Sciences, AIMS, had just opened in Ghana. And AIMS are Pan-African Centers of Excellence across Africa. It brings together Africa's brightest students with the goal that we are giving world-class training, and we use our skills and knowledge in maths to solve the challenges we face in Africa. So I went to AIMS after undergraduate at the University of Ghana, and my goal was to explore more maths. It was at AIMS that I met my should I say my mentor, Uli. So Uli was teaching a course in algebra. I love algebra, and I kept on asking lots of questions. So during lectures, so AIMS, our model is a semester's course is taught in 3 weeks because our lecturers are volunteers who come from across the world. So it's quite intense, but it's also a 24-hour learning environment. It's fully funded, so you are accommodated, like giving meals and stipends. So our lecturers live with us, and that means you can have access to them anytime they're in the office. So in the mornings before class, in the evenings, I'm asking questions. I asked lots of questions, and Uli realized I was really interested in math, and I was still not sure what I wanted to do. And he said, okay, you can do this 1-year postgraduate diploma at ICTP, the International Center for Theoretical Physics in Italy. That could give you a more time to explore. And it was me coming from University of Ghana, more of a Ghanaian stage. I went to AIMS, an African stage, and in ICTP was a global stage. We were nine in a mass class from across the board. The country, the cultural shock, the educational system was different, but I also had to take up that challenge that if I really wanted to do maths, I needed to learn at any level, whether it's local or global. So I put in my best, and it at ICTP that only knew I always wanted to study in the UK, but getting funding was a challenge. The School of Maths and Stats at the University of Glasgow only met her and inquired how she got funding to study in the UK, and she mentioned the Schlumberger Foundation Faculty for the Future Fellowship, which supports women in STEM from developing countries to study at top universities abroad, with the goal that we return to our home countries to promote the teaching and learning in STEM. So it was around November 2015. It was almost a week to the close. So I had to put in my all that week. I had girls in STEM in Ghana. I'd been involved in a lot of these activities, so I could get examples for it. I also had to demonstrate my academic excellence, my teaching and research excellence, which I did. And I was hopeful that I would get it. So I got interviewed for the scholarship, but that wasn't a guarantee. So in March 2015, I was studying in the library and I got an email, and I had a way, there's a way you read an email by just checking for your notifications, the first few lines. So I did that, and I saw it was quite positive. So I read the whole email, and it said, congratulations, I've been awarded the Schlumberger Foundation Faculty for the Future Fellowship. And for me, that was a dream come true, because growing up, I dreamt of studying in the UK. And secondly, I dreamt of becoming a lecturer at the university, and I needed a minimum of a PhD. So this took me to the University of Glasgow in the UK, where I studied for a PhD in mathematics, which was eye-opening. I did a lot of maths, but I did a lot of outreach, working with high students, summer schools, communication by competing in the Science Slam, going into the European Science Slam finals. But after all these experiences, my goal was to return to my home country, Ghana. So after I graduated with my PhD in 2019, I returned to Ghana. I started with a postdoc at WiMS Ghana, where I did my previous master's, and I'm now an academic manager for program, or think of non-commutative algebra. So that's a bit of my journey to my maths field. Yeah.
I just wanted to say congratulations on the scholarship. Also, sort of on the same note, I saw that you were named World's Most Interesting Mathematician in 2024, and I was just wondering, how did you sort of get there, and what challenges did you face along the way?
Yeah, so the world's most interesting mathematician. Yeah. So yeah, in May this year, I received an email from Sir Christian. He manages aperiodical.com. They organize a website that organizes the competition for the world's most interesting mathematician. So the first one was in 2018, and one of my mentors, or my Black heroes, so Naira, and he's a mathematician in the UK. He won the maiden edition in 2018. So the goal of the competition is that you let mathematicians from across the world pitch interesting math ideas. So you pair at each stage, and you let a worldwide audience vote for the most interesting pitch until you get to the finals and you have a winner. So in May, I received an email from the organizer that Naira had nominated me to participate in this. And yeah, I was honored, but it makes a big challenge, right? You are competing with 15 other world-class mathematicians for this award. I said, okay, if I've been nominated, it means that I have the capabilities, so I would give it a try. So I started by, so I'm a science communicator, and I try to explain maths to a general audience. So in my first pitch, I spoke about mathematics for machine learning. At WiMS, I taught courses in mathematics for machine learning, where I talked about in data, when we are storing data, we store them in containers, which we call vectors. What do we do with vectors? We can add or scale them. I talked about calculus and how relevant these are to us, and related to the fact that now this ChatGPT, we all are using all these AI models these are built heavily on mathematics. So that was my first goal, to reach people that, hey, anytime you are using all these tools, you use maths. And people loved it and voted for me, and I made it to the quarterfinals. Now, in the quarterfinals, I was pitched against Howie Wise in the US, and he has a lot of following. He does more math tricks for high school students, and that was for one of the biggest hurdles. And then I pitched about a quantum world. So 2025 has been declared by the United Nations as the International Year for Quantum Science and Technology. And my research is in quantum algebra. When we say quantum, people think of it as a very big word, right? But I try to use simple things. So in my introduction, I was wearing a shoe before a socks, and on my other foot, I had a socks before a shoe. And it was very visible that both had different outcomes, right? So the order in which you wear a shoe and a socks matters. But if you think of addition, 2 plus 3 is the same as 3 plus 2. So the order in which you do addition doesn't matter. We call addition commutative, and the shoe and socks, or even think of subtraction, 2 minus 3 and 3 minus 2 are not the same. We call that non-commutative. So my research looks at abstract notions of these non-commutative things along the line of dictionaries. So if you look at the dictionary, you have what alphabets, you form words which have meanings. But if we take a word, I'm focusing on English, and we rearrange the alphabets, usually you have a different meaning. So for instance, if you take the face, F-A-C-E, if you rearrange the alphabets in face, you get cafe, which means something different. So I highlighted the fact that there's some quantum. So quantum here means just non-commutative, so that everyone will know that, okay, there's some quantum things around us. People loved it. They voted for me. I made it to the semifinals. Now, in the semifinals, I was pitched against Aiden, who did something interesting about music, maths, and counting. But I wanted to do something for the society which I have grown up in. So I live in Ghana, and I did something about 6 everyday examples of mathematics. In Ghana in the morning, when you wake up, people usually buy porridge. We buy a lot of street food, and it's usually in a cylindrical container. So you can think of something cylindrical. And if you want to calculate the volume of the cylinder, you can think of, now, if you look on top of the cylinder, you see circles, right? So if you want to calculate the volume of this, you can think of you adding these circles, the height times, and that helps you to calculate the volume, the formula we have for volume. So I spoke about that, about crossing the road or joining the road, how we use math to calculate speed to ensure you don't get into a collision. And finally also about the clock. We learn about modular arithmetic, right? Which is around us in terms of the clock. We live in a 24-hour earth, but our clock is 1200. So if it is, for instance, currently the time here in Accra is 13:24, but we usually say it's 1:24. Why? Because we divide 24 by 13, and the remainder is what we say is the time, right? So I spoke about these 50 people voted for me, and I made it to the finals. Now in the finals, I was pitched against Matt, who is from the US, and you're from the US, so you know how massive your country is in terms of following, and I needed to pull up some tricks. So all this while I've been talking about quite general science communication things, but in this final page, I wanted to delve more into math. So I started with pi. If you're illustrating pi in a high school or a primary school lesson, in a hands-on activity, you come with circular objects and threads. You use your thread around your circular objects, you measure the length, and you also measure the diameter, and the ratio between the length and the diameter will be constant irrespective of the size of the circular object, which is pi. I went further to talk about the fact that if we take pi, the number pi is irrational, right? And if you write down as many decades of pi that you have, and you consider prime chance of it, we want to look at an interesting fact about prime numbers. It turns out that for any prime number greater than or equal to 5, if you square it, it is divisible by 24 with a remainder of 1. So for instance, 5 squared is 25 and divisible by 24 with a remainder of 1. 7 squared is 49, divisible with a remainder of 1. And so I talked about that interesting fact. I linked it with, so my fellow finalists, Matt, had talked about golden ratios. So I talked about the Fibonacci sequence, linking it to the golden ratio. And yeah, people found it interesting. Was quite tough. Of course, the finals meant was two of the best competing, and finally I was adjudged the winner. And for me, it was quite surreal, right? A dream come true, because I've been working on maths professionally, but also on science communication for a while, and to be recognized on that global stage was very fulfilling. Yeah.
Sounds good. That was honestly really amazing. I was also just curious about sort of any memorable moments you've had either like with your students, with your work, speaking at events, as well as sort of how you encourage your students or like the people around you to pursue a career in mathematics.
Yeah, I think the most recent one would be the title, right? As the world's most interesting mathematician. So I've seen people either comment on social media or tell me in meetings that this means a lot to them, in the sense that they've seen a woman win this, but also someone of color win it. It also gives them that inspiration that they can actually become the world's best in any field that they have. So I see it as I'm very inspirational. I like to inspire young people. And as a young person, I dreamt beyond my surrounding. That's irrespective of where I'm from, I could go anywhere and be the best. So this current award as the world's most interesting mathematician is inspiring a lot of young people, irrespective of where they are from, that they could become the world's best in anything they put their minds and hands to.
Sounds good. And sort of to end off, I was wondering if you had any sort of pieces of advice, recommendations, suggestions, honestly, anything for young students who are interested in pursuing like mathematics or just some sort of like STEM career in the future.
Okay, so I usually say 3 things after my talks. First, dream beyond your surroundings. I grew up not seeing any mathematician around me, but I dreamed that I could go anywhere, irrespective of whether I could afford it financially or what. I dreamt beyond my surrounding, which is something, and for your imagination or dreaming, you don't pay for it, right? So if you're a young person, dream, have big dreams, but also, secondly, believe in your dream. Believe that whatever you are aspiring to, you can actually be it. When I thought of becoming a mathematician, it sounded like something, a very big hurdle, right? Doing a PhD, being awarded a PhD from a UK university, but I believed that I could actually do it. So believe in your dream, but also find people who believe in your dreams to be your mentors. I'm not here all by myself. I've had mentors who have held my hand at every point in time, telling me about opportunities, writing recommendation letters. So find people who believe in you to become your mentors. And finally, take action. Math is very challenging, right? You don't become good at math by just staring at things and not getting your hands dirty, right? So you have to constantly work. Sometimes at dawn, you'll be sleeping and ideas come and you have to get to write it down so you don't forget. You can be working on a research problem for years with no breakthrough, but it's more of you constantly coming back at it. Then you finally get a breakthrough. So those would be my 3 words: dream beyond your surrounding, to believe in your dream and find people who believe in your dreams, and finally take action to make your dream a reality. Thank you so much for having me on your channel.
Thank you.